All right, everybody. Dr. Imfan Akpan here. And I've been waiting, I've been wanting, I've been wishing for ChatGPT 5.6. And there's been a lot of rumors about it. And I want to talk about what we've got going on and what we've heard about it. And I want to get some reaction to it. And that's what this video is about.
Really interesting to see just how crazy it is. And this is something that I didn't see anyone talking about this on the timeline. GPT 5.6 solves unsettling agent behavior. So the agent behavior is arguably GPT 5 often goes beyond utility, including the machines claiming researchers verified and claim the test instead of just doing the task. The benchmark result couldn't be treated as a clean result of raw capability. They're basically trying to say that, look, this model was just acting very strange, and we don't even know if we can trust the model's results because it didn't even want to participate properly. And so,
let me go back. Sorry. Let's go back.
So OpenAI are finally introducing their newest models, GPT 5.6 Sol, GPT 5.6 Terra, and the GPT 5.6 Luna. Now,
so they renamed the models. So we've got Sol is the big one, Terra is the in-between, and Luna is the smaller.
This is really interesting because this comes at a time where GPT 5.6 isn't being released publicly for us. And I'll dive more into that later. So let's dive into this. They are announcing 3 new models. GPT 5.6 Sol is going to be the largest model, the frontier model, or I guess you could say all of your complex tasks. GPT 5.6 Terra is going to be the balanced and efficient model for everyday use. And then, of course, you will have GPT 5.6 Luna for your fast/high volume tasks. So essentially, they went from max to medium to mini. And essentially, you can think of this as OpenAI changing their names from max to mini and medium to the style of Fable, Opus, Sonnet, and Haiku. Okay, so you can think of this as Opus for GPT 5.0 and Haiku for GPT missing in this announcement, which is unfortunately buried in there, is that they're actually announcing a new max reasoning effort to give Sol the most time to reason deeply. So for the max model, they're essentially introducing a new ultra mode that goes beyond the capabilities of a single agent by leveraging sub-agents to accelerate complex work. They're calling this the GPT 5.6 ultra. So rather than just one model spinning up, it spins up sub-agents to accelerate more tasks.
So you'll have a group of agents working along with the main model. So if you think about how we have reasoning, so the model is working, talking to itself, working through the task. This gives you smaller agents to work on that task at the same time.
To be super interesting. Now, the first benchmark that we're going to be looking at is rather interesting because this is a section that talks about the fact that GPT 5.6 Sol is actually beating Claude Mythos. If you don't know what terminal bench is, I'm not going to spend much time diving into benchmark maxing and all of that crazy stuff, but essentially, terminal bench basically is how well the agents use a command line. Instead of just asking the model, can the model answer a question or can I code patch it? Can the agent sit inside a terminal, run the commands, edit the file, install dependencies, debug errors, and finish a real task end to end? So this was built by Stanford, and the reason that this benchmark is one of the first ones for GPT 5.6 Sol is because when we actually look at this, on the left-hand side, you can see that GPT 5.6 Sol Ultra and GPT 5.6 Sol actually does beat Claude Mythos, even though it's a very small amount. It actually does surpass Claude Mythos, which was, of course, this scary model. And it really does surpass Claude Fable 5 by a real big amount. So this is super surprising because even the GPT 5.6 Terra model surpasses Claude Fable 5, which means if we're looking at where OpenAI are focusing, it does mean, and I'm going to show you guys why later on in this video, why this is not just like one benchmark with a small improvement, why this is even bigger when you look at the other factors. And yes, I would argue that this chart is probably one of the most confusing charts just because of the way things are, but let's dive into the next one. So the next one that we have here is exploit bench, and this benchmark is super interesting for a variety of reasons. So I think the reason that most people were focused on this benchmark is because number one, GPT 5.6 is competitive with Mythos Preview, and it's actually basically so much cheaper than Mythos Preview or Mythos 5, whatever you want to call it. And I think this is really, really important to know because GPT 5.6, and I'm going to show you guys why later, is shaping up to be a model that I think a lot of people are actually going to switch to and use because it seems better in many of the areas where you'd want to use it. So GPT 5.6 Sol, Terra, and Luna, they all demonstrate strong improvements in cyber capabilities as they increase the reasoning. And the exploit benchmark is essentially testing how capable AI agents are at real software exploitation, not just coding trivia. So the exploit bench basically gives an agent a real patch vulnerability and asks, can you work your way from I found the bug to can I exploit it? And so that is what the benchmark is doing. Now, I do want to say that I will dive into later, okay, how all of the model restrictions and stuff is going to go on. But I do find it interesting that if you take a look at where Mythos 5 is and where GPT 5.6 is, it stops right just under that Mythos 5 level. Very, very interesting if you ask me. Now, of course, I think this does show that OpenAI are very much still in the race and poised to lead if they continue developing models at this stage. And once again, if we look at Exploit Gym, we don't actually have the Fable benchmarks here, but this basically just asks if the AI agent can turn known bugs into working attacks. And essentially here you can see the quality. Now, of course, this is a little bit concerning, but at the end of the day, this is where AI is headed. Now, it's some more interesting things. I think some stuff that people did miss in the areas, okay? And I'm talking about the areas of the actual papers called the system card. Now, something that I found to be pretty ridiculous is that one of the things that you're measuring is the hallucination. So you can see here that there are still an absurd level of hallucinations in AI models. Now, on cases users already flagged as factual error prone, this is what this benchmark is doing. So the data set here is basically here are conversations where previous models already messed up. Now test the new models on those same cursed cases. And OpenAI describes this as not really representative of ordinary production traffic. And of course, hallucinations remain a hard problem, but it does really show you how models are still managing to hallucinate. And the fact that when we previously thought that with more models, with more compute, it would solve this issue, it doesn't really show us that there's any meaningful
I think this is important to talk about because when you look at it, it's a little bit above 10%. It's below 20%. And when we talk about this, what is the human error rate? And you can see that human error rate is somewhere around 10, depending on what the task is. It can be as high as 20%, it can be 10%. And I think the key point is that human error rate is not zero. So if you think about it, if it's error-free, that's perfection. That does not exist with us humans. So we see this and it's inching closer and closer to 10%. It's moving in that direction of 0%. So, when you think about this and compare the model to using or having a human do the task, are we comparing apples to apples? Is this the same? Are the models better or getting 100% error rate in some areas and then 10% in others? And as we know, humans are not perfect. So humans are not getting 100% in areas. Or, so I think it's interesting to understand that and to also look at what we will tolerate from humans and what we will tolerate from machines. The other thing I wanted to mention too is if you think about, does that error rate decrease if there's a human in the loop? So if you're using the AI and it's got, a 15% hallucination rate in a certain area, does that decrease if you have a human in the loop working with it? So does the error rate drop to 2% to 1%? Is that a likely scenario? Because if we're thinking about AI, it's initiated, it doesn't run itself. So it's initiated the input. It started with a human and then you get the output. And with that, does the hallucination decrease if the human is using it? For me, the logic says it would. If you're generating and then reviewing what you're working on, then definitely that would decrease the hallucination rate. Would that make it better than if the human did the work themselves? I think that's something interesting to look into, and that's a question to be answered.
Improvements in these models. In fact, you could argue that the newer models actually hallucinate even more, okay? Which is a little bit concerning. And the thing I would say here is that what this, information should be relaying back to you is that you still need to ground your answers. So if you're going to be using GPT 5.6 Sol, GPT 5.6 Terra, any of these models, in fact, any AI model, this means you need to be still checking your models because the world is messy. There are long tail facts. There is still data. There's ambiguous questions. There are fake sources, change details, niche topics. These are all of the areas where hallucinations happen. So think about it like this. The model can be good for reasoning, but can still reason from a false premise. And you have to understand that this is something that is probably going to persist until we develop new architectures to solve them. Because the way how LLMs are built inherently, hallucinations are essentially a part of the design. So you have to understand that if you're trying to do market research, if you're trying to do medical advice, factual claims, ground your data, ground it in data, have it, with citations and have it checked, okay? Because this is something that I think a lot of people do miss, and a lot of people just take what they're getting from the AI at face value. So ground
USA's Safe Pilot rewards safe drivers with up to 30% off your auto insurance premium at renewal.
your AIs, ensure they're working from docs, ensure if they're saying something is completely cited, because a lot of people are going to miss this. Now, you might be wondering, okay, well, this model seems smart, but Fable 5 was designed to work, and this is a model that actually looks like it was just designed for benchmark maxing. Now, this is where we start to get into a really weird area, because essentially, Meta, the company that essentially measures how long a human task AI can do by itself, actually struggles to measure just how good GPT 5.6 is, because the model was acting strangely. The problem is that they tried to estimate GPT 5.6 time horizons, but the estimate got super messy. And why was this? Well, GPT 5.6 had some runs looked where it was cheating, okay, and gaming the benchmark. Now, not necessarily malicious like a human villain, but doing things like making the benchmark pass without really solving the attended task. So they decided different ways to count those weird runs, and they looked at, many different runs, and, counting cheating attempts as failures is around 11 hours, and counting some failed cheating attempts as legitimate failures as success puts it at 270 hours. And so the entire range for this, if you're wondering how long can this thing autonomously work for, the funny part is the range is from 13 hours to 11,400 hours. So their best guess is 71 hours, but the uncertainty is so huge that it could be way lower or way higher, which is one of the times where they say that this is the first time that the error bars literally break the chart, which is insane. So, I mean, this is something that it's probably good at long software/research tasks, but Meta cannot confidently say exactly how good, because the model is beyond the benchmark's measuring range, which means we're going to have to get a new benchmark for this. Now, something that you guys are going to want to pay attention to is pricing, because everyone, and I know everyone, is, right now feeling the credit crunch because these constant models are being updated in terms of the pricing and usage. So pricing is going to be something that you have to pay attention to. And right now, it looks like that GPT 5.6 Sol is going to be a model that is far more cost effective. The same for
Okay, I wanted to end it here because I wanted to talk about the benchmarks, and I think the benchmarks are very important. And what we're seeing now is that the models are getting so good. We're seeing that they're reaching 90% in these benchmarks. And eventually, as he mentioned, which I believe, we're going to have new benchmarks. And the model, and I think looking at these benchmarks, I don't think they're the end all. I think they should be more viewed as an estimate, or the benchmark should be telling us this is around the area that we're at now. This is our best guess of the performance in this particular area. And meaning the models have gotten so good that at certain tasks that we need to rethink how we assess them. The other thing is, I think we need to look more and more how we're comparing these models to how humans would work on these tasks. So we're benchmarking them against each other on certain tasks, and they're pretty much maxing out these benchmarks, but how do they compare to human beings? And I think that's important. How do we benchmark them against humans? So if a human being would score, and the best of the best at a particular task would score 85%, and you've got an AI scoring 90%, what does that mean? You know, do we not use the AI? Is it a failure because it's not 100%, but it's better than the best of us? So I think that these are some of the things we need to look at. I know there's an exam, humanities last exam, if I'm saying that correctly, where many of the models do not score. Well, they're getting better and better at it, but humans are very good at these tasks. What does all of that mean? Because from what I see, these models are amazing at doing work on your computer. And it's really, at this point, it's like you've got an extra person with you. How do we measure that? Has it gone from, you know, having 50% of an extra person to 85, to having 2 extra people to 3 extra people? These are the things I think we should start thinking about. And I'd like to hear your thoughts on this as well. So if you really like this, make sure you like, subscribe, and comment. I really appreciate everybody on YouTube. I get a great deal of comments on TikTok